Let's take a look at the following system of linear equations. We have 4x minus 3y minus 8 plus 2 equals 0. And we also have x over 2 minus y over 2 equals 1. All right, so this is our system of linear equations. We have equation 1 and equation 2. So when we want to solve it by substitution, the first thing we want to do is take one of the equations and solve it for one of the variables in terms of the other variable. So let's go ahead and take the second equation. This looks a little simpler, even though we have fractions, but I'll show you why in a second. We have x over 2 minus y over 2 equals 1, and we want to solve this thing for x. Doesn't matter either one, let's just go with x. We want to move this to the other side, so let's go ahead and add y over 2 to both sides. These two terms will cancel, so we have x over 2 equals, let's go ahead and put our variable out front and separate it, so we have 1/2 y plus 1. Now we can isolate our variable x by multiplying through everything by 2, which will effectively kill these two denominators. So this is actually kind of simple to solve for. And that'll leave us with x on the left-hand side. On the right-hand side, we'll have y plus 2 times 1 is 2, so we'll have y plus 2. All right, so we have our variable x solved in terms of y. So what we're going to do is we're going to substitute y plus 2 in for x in our first equation. It's called substitution. So we have 4 times x is y plus 2 minus 3y minus 8 plus 2 equals 0. All right, so we have a single equation here with a single variable, and we want to solve for y, and we'll get a value for it, which is ultimately what we want to do. So let's go ahead and distribute the 4 into the parentheses here, and the minus sign into these parentheses. So we have 4 times y is 4y, 4 times 2 is 8. Distributing this minus sign inside the parentheses, so we have minus 3y and plus a negative and a negative 8. Then we have our plus 2 and our 0. All right, so now this is fairly straightforward. We're just combining like terms. So we have 4y and minus 3y is a positive y. We have 8 and 8 is 16 and 2 is 18. So we have y plus 18 equals 0. We subtract both sides by 18. We get y equals a negative 18. All right, so we found our first value. We have y equals minus 18. Now we can just pick either equation and substitute in minus 18 in for y. Let's go ahead and do the second one, because once again, that's actually, although it has fractions, it's actually a bit easier. So we have x over 2 minus a negative 18, which is y, divided by 2, equals 1. Now we just go ahead and solve for x. We have x over 2. We have minus 18 over 2 equals 1. We're just dropping this parentheses. We'll add the extra step. Let's go ahead and add 18 over 2 to both sides. Plus, if you want to look at 18 over 2 is 9, that's the same thing. So those two will cancel. So we have x over 2 equals 1 plus 9 is 10. Let's go ahead and multiply both sides by 2 so we can get rid of this denominator. We have x is equal to 2 plus 10 is 20. And there you go. So we have a value for x, a value for y. So let's go ahead and write our solution to this system of equations. The solution is going to be the point 20 and minus 18. And again, we can plug these into both equations and they'll hold true. This is the point where these two equations intersect. This is actually a special equation that we'll deal with in a later section, I believe on factoring. We'll be graphing this. So let's take a look at another one. We'll see that one later on. Let's take a look at the system of equations. 2x equals 20y and minus 2 times minus 2x plus y, close parentheses, minus 1 equals 11. All right, so this is a system of linear equations. We have two equations here, and we want to solve one equation for one variable in terms of the other variable. The equation on the left sounds very friendly to me, so let's go ahead and solve that. Let's go ahead and solve it for x, since we already have x on the left-hand side. It'll work either way. So let's go ahead and divide both sides by 10. Those two terms cancel, so we have x. These zeros will cancel. X equals 2y. So this is the expression, even though it's one term, this is the expression that we're going to plug in for x into our second equation. So let's go ahead and substitute. So we have minus 2 times minus 2 times x, which is 2y, plus y, minus 1 equals 11. All right, let's work outside of the work inside these parentheses, work inside out. So we have minus 2. We have minus 2 times 2y is a minus 4y plus y minus 1 equals 11. All right, let's go ahead and we're still working on the inside of the parentheses. Minus 2 times, we have minus 4y and plus 1y, so we have a minus 3y minus 1. Let's go ahead and add this to both sides. So we have 11 plus 1, which is 12. We just move this to the other side by adding 1 to both sides. We just skipped a step. Minus 2 times minus 3y. These two negatives will cancel, so we have a positive 6y equals 12. We can divide both sides by 6, which will isolate our variable y, and we get y equals 2. 12 over 6 is 2, so y equals 2 is our value. We can plug that in. All right, we can plug that into either equation, but again, this one looks fairly friendly. So let's go ahead and we have 10x equals 20 times y, which is 2. That'll give us 10x equals 20 times 2 is 40. Let's go ahead and divide both sides by 10 to isolate our variable x. These two zeros will cancel. So we have x equals 4. This is actually a very friendly looking answer that you won't see very often. We have two whole numbers. They're both positive. They're both very small. So we kind of looked out here, but this is the exact point where these two lines intersect. They intersect at x equals 4 and y equals 2. All right, so I'll leave you that to check. You can actually plug in 4 for x and 2 for y, and these will actually ring true. 10 times 4 is 40. 20 times 2 is 40. And I'll leave you to check the other one. So in the next section, we'll look at a few applications where solving linear systems of equations with substitution will actually be very useful. So I'll see you soon.